turn a pile of scrap and 3D prints into a high-tech autonomous robot. In this video, I'm showing you exactly how to build a heavy-duty, omnidirectional mobile robot from scratch. Make sure you stay until the very end of the video to see the full breakdown of the salvaged parts I rescued from the junk pile to make this build possible. Let's start with the build. We'll begin by assembling the front wheel holder. First, insert the bearing into the housing, flip the assembly over, and then insert the wheel standoffs. Note that these M8 nuts will be secured a bit later on, once we install the threaded rods. Now let's move on to the middle section. Slide the battery holder into position and secure it down using the bolts. We will follow the same exact procedure for the M8 nuts here as well. They'll be fully tightened once the threaded rods are in place. The procedure is identical for the back wheel holders. Insert the bearings into the housing, position the rear middle piece, and then the front middle piece. Simply repeat this exact process for the opposite side. The components are identical, just mirrored. Make sure that you insert all nuts, otherwise the disassembly will be required. Now, it's time to insert the threaded rods. Pay close attention to the threaded rods lengths here, as it's crucial that they are positioned in the exact correct location, longer up, shorter down. Next, we will assemble the planetary gearbox. Insert the small bearings and then secure the entire assembly together using the bolts. Repeat this exact procedure for the remaining planetary gears. Once you have assembled 3 of them, insert the sun gear and then install the 4th and final planetary gear. Next, insert the nuts and the rear bearing. To successfully assemble the ring gear, you will need to stretch it out just a little bit. Once it's ready, insert the entire assembly into the housing. Install the bevel gear next, making sure it is firmly pressed against the inner gearbox. With that in place, we can assemble the motor mounts using the M3 bolts and install the NEMA 23 stepper motors. You can tighten the sun gear to the motor shaft from above. Now attach the gearbox holders using M3 bolts. Insert the M5 nuts from the other side. It is incredibly important to tighten these firmly right now, because once the build progresses, these 4 M5 bolts will be completely unreachable. Install the bearing, followed by the output bevel gear. On the opposite side, install the standoffs, insert the wheel shaft, and lock it firmly in place using the set screws. Make sure that the M5 threaded rods are inserted to be flush with the bevel gears. Then tightly bolt the set screws, otherwise the wheels will slip. The motor will have resistance on the bevel gear, so use the pliers to align the set screws. You will then repeat this exact sequence for the remaining gearboxes. Now let's install the battery mounts and the batteries themselves. If you plan on using a smartphone as a depth camera for this build, now is the perfect time to install it. The CAD files include adjustable parts for the phone holder, so you can easily customize it to fit your specific phone model. Next, we'll begin assembling the electronics. Mount the ESP32 module, but leave the screws slightly loose for now. Install the DC converter and use a multimeter to tune the potentiometer until it outputs exactly 5 volts. This detailed schematics will be in the description bio, as well as the firmware for the ESP32. We can now begin installing the outer panels, starting with the sections that house the ultrasonic sensors and the LED strips. Secure everything using the provided bolts and repeat the process for the front panels. All of the outer panels are secured using standard M3 by 10mm bolts. Install the remaining LEDs followed by the main power switch and the female DC connector intended for the robotic arm. The remaining panel pieces are assembled in the exact same manner. For the sake of time, this tutorial only demonstrates one side of the build, but the opposite side is perfectly symmetrical. So simply mirror these steps to finish the enclosure. Finally, let's install the wheels, ensuring they are properly aligned. The outer side of the wheel assembly uses 6 M3 by 20mm bolts. Secure the wheel halves together, and then insert the 9 cylinders. Make sure the cylinder pins slide all the way into their slots. Before mounting the wheel assembly onto the wheel shafts, be sure to use plenty of washers. The wheels are secured by M5 nuts from both sides, and you'll want to tighten them as strongly as possible to prevent any slipping during operation. And that's it. Your assembly is complete. I scraped stepper motors from old office copy machines. Next, I made LiDAR sensor from old phones cameras. Then I pulled powerful lithium batteries from cordless drills. Finally, I turned an optical mouse into the distance sensor. Detailed explanations will be made in the next videos. Stay tuned.